Okay, this is day 6 of Unit 4. We started today with a homework quiz, so if you were absent, you'll need to make that up. And then we worked on this warm-up. So you should pause the video to try the warm-up and then play to check your answers. So the first question, I can factor by grouping, factoring out an x squared. I'm left with 3x minus 4, and then copying that 3x minus 4 times, looks like negative 9 would give me negative 27x plus 36. So then 3x minus 4 is the GCF, and I'm left with x squared minus 9, which factors into x plus 3 and x minus 3. So the quantity 3x minus 4 times the quantity x plus 3 times the quantity x minus 3. Letter B is difference of cubes. So binomial and a trinomial. Cube root of 27x cubed is 3x. Cube root of 125 is 5. Signs minus plus plus for difference of cubes. Squaring the quantity 3x gives us 9x squared. Squaring the 5 gives us 25. And 5 times 3x is 15x. Again, with signs minus plus plus. Number 2, rewrite in vertex form by completing the square, then state the vertex. So we first have to factor out a negative 2, which leaves us with negative 5 halves x, 1's on the end. So then I'm dividing negative 5 halves by 2, which means I'm multiplying by 1/2, which gives me negative 5/4. After dividing by 2, I'm squaring that. So that gives me 25/16. So 25/16 is what I add, but it's not actually what I added because there's a negative 2 in the front. So 25/16 times negative 2 over 1. I'm going to simplify on the diagonal before I multiply. So 2 goes into both of those, so negative 1 and positive 8. So negative 1 times 25 is negative 25, and 8 times 1 is 8. So 25/16 times negative 2 is negative 25/8. So negative 25/8 is the amount that got randomly added, which means to balance this equation, I have to add positive 25/8 onto the end. So we have y equals, we have a negative 2, and we have a quantity squared. We go back to what we had before we squared, which is x minus 5/4, the quantity squared. And then 1 in eighths is 8/8. 8/8 plus 25/8 is positive 33/8. That is my equation in vertex form. And the vertex 5/4, positive 33/8. So today we looked at solving quadratic equations using a couple different techniques. The first technique here is using square roots. So go ahead and put these in your notes. To use square roots, first of all, that technique is only used when there's no x term. So if you look at this equation, you'll notice there's no x. So that's a good candidate for square roots technique. And what I need to see is x squared all by itself equals a number. So I need to get that 17 away. So if I add 17 to each side, I'm getting 24. I still can't take the square roots yet. I need to get rid of that 2. So dividing both sides by 2 gives us x squared equals 12. Now I'm ready to use the square roots technique, which means take the square root of each side. So on the right, we can simplify the square root of 12. We know that's 2 root 3. And on the left, be careful and think about this carefully. Think back to Unit 1. We're taking an even root of something, and when I take an even root, first of all, I'm getting x to the 2 halves, 2 divided by 2, the exponent divided by the root, which is x to the 1. So I know that's x, but I'm remembering this is an even root of something that's coming out with an odd exponent. And remember, we learned earlier in the year that we need the absolute value around that. So again, it's when it's an even root, which this is, that comes out with an odd exponent, it needs absolute value. So I need absolute value of x rather than just x. So then to get rid of the absolute value, I need to make my answer both positive or negative. So I have two solutions to this quadratic equation, positive 2 root 3 and negative 2 root 3. So I'm going to use the same approach on this problem. I'm going to subtract 4 first. Next, I can't take the square root yet. I got to get rid of that 32, so I'm going to divide. So I have x squared equals 1/4 when I simplify that. Now I'm ready to take the square root of each side. So once again, the square root of x squared is the absolute value of x. The square root of 1/4, we know how to do that. We've been working on those. Square root of 1 divided by square root of 4, which is 1/2. So x is equal to plus or minus 1/2. Okay. Next. So now we're going to solve by completing the square. So notice the directions change. They say completing the square, not square roots. That's because if you look, this time we have x's, so I can't use square roots technique. What I can do is complete the square like we've done the last several days when we tried to get quadratic equations into vertex form. So the first couple of steps are pretty much the same. I'm going to get the 7 over so that it's in standard form by subtracting. And after I've done that, now I can group just like we've been doing. I'm going to skip just a little bit of space there. So now I have half of 6, which is 3. 3 squared is 9. So 9 gets added to complete the square. So because I added it, I have to subtract it. So this binomial squared is x plus 3, the quantity squared. Remember, that's what we had before squaring, which is plus 3. And negative 7 minus 9 is negative 16 equals 0. So from here, I have something squared, and if I get the 16 over to the other side, I'll have something squared equals a number, which at this point, we will be able to solve by square roots, okay, like we did in the first two problems. Also notice if the directions were to rewrite in vertex form and this was equal to y, then I'd be stopping right now because this would be vertex form. But we're no longer just rewriting in vertex form. Now we're using completing the square to solve. So from this point on, the problem is going to be approached differently than what we had done previously. Previously, we would stop because this would be done. It'd be in vertex form. We're going to go ahead and solve. So I'm going to add 16 to both sides. And now that I've done that, I have something squared equals a number. So now it's set up perfectly for square roots technique. So with the square roots technique, I can take the square root of the quantity x plus 3 squared, which is the absolute value of x plus 3, and the square root of 16 I know is 4. So to get rid of the absolute value, I make my solutions plus or minus, and of course I'm going to subtract 3. And when I subtract 3 from positive 4, I get 1. And when I subtract 3 from negative 4, I get negative 7. So the two solutions are 1 and negative 7. Okay. Now realize you may have at the very beginning thought to subtract 7 and then factor that, and you would have probably gotten the solutions much quicker. Factoring is another technique for solving quadratic equations sometimes if they're factorable. This one would have been, so that would have been a possibility. However, the direction said to solve by completing the square. Okay, so once again, we'll solve by completing the square. We're going to subtract 4. So I'll group the x squared and the 10x, skip a little space, I have minus 4, skip a little space equals 0. So half of 10 is 5, 5 squared is 25. I'm going to subtract the 25. So I have x plus 5 is what I had before squaring. Negative 4 minus 25 is negative 29 equals 0. So now I'm ready to add 29 to each side. And now I'm ready to take the square root of each side. So I have the absolute value of x plus 5 is equal to the square root of 29 does not simplify. So to remove the absolute value, I'll make my solutions plus or minus. And last, I'll subtract 5. So negative 5 plus or minus the square root of 29 are the two solutions for x. That one would not have been factorable at the very beginning. Okay, so we would have to use a different technique, either like we did here, completing the square, or quadratic formula would also work. Let's try a couple more. So again, we're going to solve by completing the square. So first I'm going to subtract the 7. I'm going to go ahead and, because I see that 2x squared, I know I can't complete the square yet, so I'm going to go ahead and factor out the 2. Skip a little bit of space. After minus 7, skip a little space, equals 0. So now I'm ready to complete the square because I have a 1x squared. So I'm going to take half of 3 and square it, giving me 9/4. 9/4 is what I'm going to add. But it's not actually 9/4, it's actually 9/4 times 2, or 2 over 1. I'm going to simplify that before I multiply. So on the diagonal, 2 and 4 become 1 and 2. So 9/4 times 2 is 9/2. So 9/2 is what got added, which means on the end I have to subtract 9/2. So I have a 2 out front. I have a quantity, x. I'm going back here. What I had before squaring was plus 3/2 squared. Negative 7 minus 9/2. So negative 7 in halves is negative 14/2, and negative 14 halves minus 9/2 is negative 23/2. Again, had this been equal to 0 or equal to y and we were supposed to rewrite in vertex form, we would stop. We'd be done. But it's solve, so we're going to keep going. So I'm going to bring that 23/2 over to the other side. By adding. I'm going to divide both sides by 2. So dividing a fraction by 2, remember, is multiplying by 1/2. So I have 23/2 times 1/2, which is 23/4. Now I have something squared equals a number, so I can use the square roots method. The square root of x plus 3, the quantity squared, is the absolute value of x plus 3/2. I can simplify this as we've been practicing these. The square root of 23/4 is the square root of 23 over the square root of 4, which is 2. Make sure when you write that 2, it's very obvious that it's not underneath the square root. It's in the denominator of the fraction. So I'm just going to come over here. I'm going to remove the absolute value by making my answers plus or minus. And lastly, I'm going to subtract the 3/2. So I have negative 3/2 plus or minus the square root of 23/2. Now, that's fine for an answer, or if you want, you may notice that the denominators are the same. So I can actually combine those two fractions and just make one large fraction, negative 3 plus or minus the square root of 23 all over 2. They're the same thing, and I would accept either answer. However, the second answer is more similar to what you would see had you solved this equation using the quadratic formula. So again, either of those two final answers are good. Okay, now let's work on the next one. And actually, I had students work on this in class, so you might want to pause the video and try it. So I have 2x squared. I'm adding 10x minus 6 equals 0. So I'm going to go ahead and factor out the 2. I'm left with x squared plus 5x. I'm going to skip a little space. The minus 6 goes on the end. Skip a little space, equals 0. So now I'm ready to complete the square. I'm going to take 5 halves and square it, giving me 25/4. So 25/4 is what I'm going to add on. But it actually wasn't 25/4 because of the 2 in the front. So 25/4 times 2, simplify on the diagonal before multiplying, is 25/2. So 25/2 was randomly added, which means 25/2 should be subtracted. So I have 2 times the quantity squared, the quantity is what we had before squaring, so x plus 5 halves. And now I'm going to combine negative 6 and negative 25 halves. Negative 6 in halves is negative 12 halves. Negative 12 minus 25 is negative 37 halves. And that equals 0. So again, if this was putting into vertex form, I'd be done, but it's solving. So I'm going to add the 37 halves. I'm going to divide by 2, which is the same thing as multiplying by 1/2. So 37 halves times 1/2 is 37 fourths. I'm going to take the square root of each side. Get this out of the way. Okay, so I have the absolute value of x plus 5 halves is equal to the square root of 37 divided by the square root of 4, which is the square root of 37 halves. So x plus 5 halves is equal to plus or minus the square root of 37 halves. So I'm going to subtract 5 halves. X equals negative 5. I'm going to make this one whole fraction, plus or minus the square root of 37, and that's all over 2. I just subtracted 5 halves, and negative 5 halves plus or minus the square root of 37 halves is the same thing as writing it as one big fraction, negative 5 plus or minus the square root of 37 all over 2. And that is my final answer. Okay. And that was the last example for today. So your homework for tonight on these pages, pages 9, 10, 11, 12, and 13, you're going to do just the odds on those pages though. Okay, so 9, 10, 11, 12, and 13, those are the pages, just the odds on each one of those pages. You do have a quiz coming up later this week on Wednesday, and that'll be on everything we've covered so far in Unit 2, or Unit 4. So that's coming up later this week.